to day 10 of the 12 Days of LiDAR. My name's Alex Billick, and today we're going to be talking about LAStools and LiDAR. Um, Now, LAStools, it's impossible to understate the impact that the founder of LAStools, Martin Eisenberg, had on LiDAR and the world of LiDAR. The LAZ compression was first published formally in February of 2013, shown off at conferences the year before, and that compression has had a massive impact on the uptake of LiDAR. The tools built within LAStools were revolutionary at the time, continue to be extremely functional. Martin was a big advocate for open data, making data accessible, usable, and just a force in the world of LiDAR. And unfortunately, he passed away in 2021. I would highly urge you to read into some of Martin's legacy and the brilliance that he had when it comes to this stuff. I've got a few links here. One is that LAS paper, which is so fundamental to understanding just being able to see through the problem and bringing about a really fundamental way of solving it. So there's some great resources here. Again, I'll make these links available to you as well. So there's a tutorial, which is sort of an assemblage of the web-based tutorials that LAStools has built over time. It's about 600 pages if you want to download the entire PDF. It covers a wide range of topics. It's more of a Control F and find the tutorial information that you want. There's a GitHub page that we're going to explore, and then the LAS paper. So the LAS paper here was published, like I said, in 2013. It was in the Photogrammetric Engineering and Remote Sensing, which is published by the American Society for Photogrammetry and Remote Sensing, or ASPRS. So you can read this. It's available. The link's going to be available. If you jump over to the GitHub page, LAStools is very important to understand. There's two sort of sides to LAStools. One is the open source tools, and one is closed source that requires licensing. Be very careful when you use LAStools, because if you accidentally use a closed source tool, it will inject garbage data. So you could run it and the tool runs, but if you don't catch the fact that it's doing that, you could end up with serious problems downstream. What's nice about that feature is that you can actually leverage LAStools and learn how to code and how to build a workflow, how to build a batch script with it fully before committing to a licensing file. So you've got lots of options here. But the open source tools that are available, some of these are fundamental tools for day-to-day use. One is LASinfo, being able to pull up very quick content of a LAS or LAZ file. LASindex, which creates that spatial index, the LAX file. What this allows is things like LAS catalog in R to understand the surrounding tiles and just pull those tiles or bits of information that are required. It's much faster to compute those using LAStools than it is to calculate those in R, so I'd highly recommend you do that here. The other one that saves me a lot of the time is LAS2LAS. What that basically lets you do is clean up a lot of problems. I mean, it has other functions, but what I fundamentally use it for is if I download data from somewhere and maybe it's been processed in a way that is non-standard, maybe it's got some garbage issues with the projections, or projections are not being defined correctly. LAS2LAS saves me a lot of headaches, being able to quickly say, okay, take my input folder, apply some of these fixes to it, or sometimes it's even just by converting it within the tool, it cleans up all the headers and solves a lot of problems. So extremely useful. This last copy index function, I haven't been able to get that working yet. I haven't been able to find it, so I'm guessing that maybe in the next version they're going to fully release that. But that's a nice feature. Basically, what that will mean is the version of a LAS file that QGIS wants, and sort of becoming more of a mainstream standard, you'll be able to generate very quickly with LAStools. So that's a nice feature to see. The tutorials, like I said, they are wide-ranging. Oh, sorry, 630 pages. You see, it starts with dealing with LiveVox, drone-based LiDAR data. It's very, very comprehensive, but you're gonna kind of have to search for the information you want. There's no simple user manual when it comes to a workflow. but all the tools are well documented if you know how to find them. So what we're going to do, when you download LAStools, you install it. It's just to the C drive. So I'm going to open up a command line window here. You can run all of this in LAStLook as well, which we looked at previously, but this is how I run it. I'm just going to run it this way because I'm the most familiar with it. You can explore LAStLook some more if you'd like to. So what I'm going to do is I'm going to first run a tool. So we're sitting within the LAStools bin folder, which is where all of the tools reside. We're going to run a tool here. It's called LASinfo. Actually, I'm just going to do this, LASinfo, and any tool that you name, you can put -H, and it will give you a help. And it will tell you all of the tools that can be run within it, and how to structure them correctly so that it works. So you see here we've got a lot of different options for filtering especially, or transforming coordinates. I'm not going to worry about any of that, but you see that we can very quickly pull that information up. But I just pulled up the LASinfo for the same tile of data that we've been working with all along here. So we can see the last software that was used. So we see that the Ministry of Natural Resources is using PDAL to generate those files right now. We can understand the way that everything is arranged, if there's any errors here, what the projection is, the breakdown by all of the classifications. And what's nice with this is you can actually run a LASinfo and merge it for a series of tiles if you'd like. So lots of functionality here. The next thing I'm going to generate, just to show you again the syntax, is LASindex. So this is going to generate a small file that acts as a lookup file, and things like R will leverage that. So the syntax here is quite simple. I'm not generating any weird outputs here, so all I'm asking you to do is to use the LASindex function. Oh, and I realize now that you can't see that line of code, so let me just pull this up somewhere you can see. There you go. So you're going to use LASindex and then -I for input, and we're mapping it to this drive here, and we're saying any LAS file within that directory, please generate us a LASindex. So it's going to go through and do that. Might take a moment. Okay, and it worked. So we generated that very quickly in about 7 seconds. The last tool we're going to use here is called LAS2LAS. So, oh, that. Get rid of all this. Forgot to define my function. All right. Here we go. So LAS2LAS, I could say LAS2LAS 64 as well if I wanted. If I was doing this on a lot of tiles, I would want to do that. But our input is defined here. Our output directory is defined. I'm going to put it in the same spot, and I'm going to export an uncompressed LAS file. We're going to let that run. This might take a moment, but that's okay. And it's finished. So now what I'm going to do is I'm going to use the same LASinfo function we just used, but I'm going to change it to .las now. And there we go. And now we see that by using LAS2LAS, we now have that the last version of software to touch this file and modify it was LAStools. So we've moved from PDAL to that. But you might have noticed up here, wherever it went. So there was some complaints about scale factor and everything else. Those can sometimes be ignored. It depends on the tool you're using, whether it cares or not. But that LAS2LAS function has cleaned up a lot of those for us. So it's really nice that it will do that. So if you're running into some problems or the tool you're using is being picky about that, we can sometimes just get around it and ignore it by using LAStools to clean it up for us. The last thing I want to say about this is that it's extremely extendable. So that you can use, LAStLook to access those tools. You can use QGIS, you can use ArcPro, and you can use R, among others, to access those tools. So it's very versatile, very powerful. Definitely leverages batch scripting as well. There are example batch scripts included in when you install the software, so you can see what the syntax looks like. But it's a tool that even if you aren't paying for it and you're just using the open source elements of it, has a lot of uses in your day-to-day workflows. LASinfo, I use that whenever I get new data in the door. I quickly will basically just run LASinfo and LASindex and see, number one, is my projection defined correctly? Like everything in GIS and remote sensing, projections are the bane of our existence. So if they are not defined correctly, we have to clean that up. And then once I know that that's good, then I can proceed on with doing other quality control checks for overlap and other things like that. But this is where I start. So I just wanted to make sure that I highlighted LAStools, the power of it, where that tool set is going, and the impact that Martin Eisenberg had on the LiDAR space and will forever have on the LiDAR space. So I really encourage you to check out that LAS paper and explore some of these tutorials if this is of interest. But either way, definitely take advantage of the fantastic tool set that is available there, keeping in mind that if you use it without licensing, you could be injecting some garbage data, so don't accidentally use it in a production workflow. With that being said, thank you very much for listening, and tune in tomorrow when we talk about terrestrial LiDAR. Thanks for listening.